So I'll just write down. I've got a printout of the practice test, but I'll just write down the parts we need. That way it'll all be together. You won't have all the extra stuff that WebAssign throws in there sometimes. Okay. Anybody have just any general questions or anything before we start doing review problems? I don't know. I haven't made it yet. It'll be in the teens probably, but not sure on. Yeah, we're just doing the same types of problems. We'll just do them. You're happy with your grade after test 3, you're finished. Yeah. Yep. And if not, if you're thinking about taking the final review for that, will be on the Tuesday after Thanksgiving break. I think that's November 30th. Yeah. a lot of it builds on itself in here. So. Okay. Yeah, that's rough, especially if you throw in like geometry and stuff in there. That's rough. I don't know how Anything else? Any other thoughts? All right, so I'll just go in the same order with the topics that they are on the review on WebAssign. So number 1, we have polynomial division. And it says use either synthetic or long division. I think we'll do this first one with long division, and then we'll do one with synthetic division, and we have 3. We can decide what we want to do on the other one. So this one, we're going to divide. (2x squared minus 5x minus 7) by x minus 2. So if we're going to do long division, we'll put the x minus 2 out in front. You could also do this one with synthetic. And then 2x squared minus 5x minus 7 would be under the little house. On these, remember, we're just looking at the leading terms, right? So we're looking at the x on the outside one, we're looking at the 2x squared on the inside one. And we're thinking, what do we need to multiply x by so that we would end up with 2x squared? So 2x, 2x. Okay. And then we distribute to that outer term. So 2x times x is 2x squared. And then 2x times negative 2 would be negative 4x. Okay. And then you remember what the next step is? Change the signs, change the signs. Sorry? You do that differently? That's okay, as long as you have a way that works. Okay, yeah. Yeah, there's different little tricks and things you can do, so. Yeah, that's okay, same thing. Okay. Yeah, so first terms here cancel. And then that will leave us with, we have negative 5x plus 4x, so that leaves us with negative x, negative 1x if you want to. Bring the next term down. And we're going to go through the same process, except we're looking at that negative x as our leading term. So to get from x to negative x, what do we multiply by? Negative 1, yeah, negative 1. So then we distribute negative 1 times x, negative x. -1 times -2 is +2. Change the signs. So here the x's cancel, and then we have -7 minus 2, so we end up with -9. And then it can ask us to give our answer two different ways. It could just ask us for the quotient and the remainder. So 2x minus 1 is the quotient part. Here our remainder would be -9. Or it could ask us to write it like this. Could ask us to write it as 2x minus 1 plus our remainder over the divisor.
So when you just ask for our remainder?
Yeah, you don't have to put it over there. You can just put -9. Yeah. Questions on that one? All right, we'll do the next one with synthetic, and then I'll let you pick on number 3.
You don't see like x squared or x, so we do have x to the third power.
If you're missing the power,
Powers, do we just
you can put a placeholder. The next one uses a placeholder, so yeah. Okay. Yep. All right, so if we're going to do this one synthetic, and again, it gives you the option to do either way. If we're going to do this one synthetic, we need just the coefficients. And like you were mentioning, we need to make sure that we've got every power of x in there. If we're missing a power of x, then we need a placeholder in that spot. But we've got them all on this one. And we got 3, 2, 1, and 0. So we can write down our coefficients. So we'll have 3, 9, -7, and -1. And then what number goes out front? You remember? Yeah, we take the opposite of what we have over here. So if it was x plus 4, we're going to put -4 up front, so -4. Okay. Then we bring down our first coefficient. And then we take our coefficient and multiply it by the number out front. So 3 times -4 is -12. And then we add, so 9 plus -12 or -12, however you want to think about that, we get -3. And do the same thing over again. So -3 times -4 is 12. -7 plus 12 is 5. What did I mess up on? Am I right? Okay. All right, that's okay. Yeah, keep an eye on me for sure. Because I was looking for a mistake when you said that. All right. And then 5 times -4, we would have -20. So we get -21 there. And that last box is our remainder. Okay, and then to write down our answer, these are the coefficients, but we've got to make sure we started with x to the third power, so our answer will start with x to the second, or x squared. So this will be our coefficient on x squared. So we'll have 3x squared minus 3x, and then it's a +5, so +5. And then again with our remainder, it could ask us to either just what's the remainder, or we could write it. Yeah. Questions on synthetic? All right, so because the thing we were dividing our dividend, its degree was 3, right? It started out x cubed, so it's always going to start off 1 less on the answer. Yeah. So since we started with a third power, then our answer is going to start with second power. Yeah, it's true anytime you do synthetic division.
Where there was 9x squared at the top, it goes.
The next one, well, no, so that's true for the biggest one, right? It's 1 smaller, and then they just step down in 1. So like we went from 2 to 1 to 0. Yeah. Yeah. And if there are any missing, like if you don't have one of the powers in your answer, you'll have a 0 up here in that spot. Yeah. Yeah. Other questions on that one? Okay. Got one more division here, and let me write it down, and then I'll let you pick which way you want us to work it. Okay, so this one, we are missing some powers of x. Yeah. So we'll go from x cubed all the way down to our constant term. So, do you want to do long division or do you want to do synthetic? Synthetic, okay. Yeah, we'll do synthetic then. So, here if we're writing down our coefficients from the one we're dividing, our dividend, then it starts with 1x cubed, but we don't have an x squared term. Yeah, we don't have an x term, that'd be 0. And then our constant term would be last, would be negative 27. Okay. And then what number goes out front? Positive 3, because it was x minus 3, so we'd take the opposite, have positive 3. Yeah, and then we bring down our 1s, right? And 1 times 3 is 3. 0 plus 3 is 3. 3 times 3 is 9. 0 plus 9 is 9. And 9 times 3 is 27. Negative 27 plus 27 gives us a remainder of 0. And then our dividend started with x cubed, so our answer will start with x squared.
Can you explain
Okay, so there's our no remainder on that one. So when we're writing down the coefficients, we need every power of x represented starting with whatever our largest was. So since this one, our largest power of x was 3, our coefficient for that one's here. But then for x to the second power, we did not have a term, so we'll have a placeholder 0. And then for just the x term, x to the first power, we have a placeholder. But then we did have our constant term, the negative 27. That makes sense. Questions on that one? Okay, I think that's all of our division problems. Parts of these with the graphs, it gives you a lot of extra stuff that I'm not super concerned with. Like the next one on the practice test gives us this function. Mine at least does 7 to the x power. It's exponential. And then the first thing it asks for is it gives us a bunch of x values and asks us for the y values. I'm not as interested in giving you a whole bunch of those to do. And the main thing I want you to be able to find is to be able to pick out a graph. Okay. So on these, our graph should look like this. Yep. It increase from left to right, and it should go through. Remember what our special point is? Yeah, 0, and then the y coordinate is 1. 2, 0, 1. Because our base here is bigger than 1, so that's the type of graph we get there. The other options that it gave us on the multiple choice is it had one going the opposite direction. That's what we would have if our base was between 0 and 1. And then the other two choices, it gives us down on the bottom going both directions, and it just doesn't match here because we haven't done an x-axis reflection. So with exponentials, you're either increasing from left to right going through 0, 1, or decreasing from left to right going through 0, 1, and it depends on the base. Here, bigger than 1, we're growing left to right. Between 0 and 1, we're getting smaller left to right. Picking out the graph on that one's what I think is the important part. Okay. Number 5. We've got 4 different graphs, okay, and we're going to match up which graph goes with which function. So we'll just write them down and figure out what the graph should look like as we go. So A gives us -2 the x. And so we just saw, like, that's what our basic exponential function looks like if our base is bigger than 1. Okay. But on this one, the thing we've done is we have a negative sign out in front of the whole thing. So what's that going to do to our graph? It's not going to be that shape we saw in the last one anymore. Putting a minus sign out front, what type of reflection is that? That's an N. It's going to make everything that was positive turn negative. That's an x-axis reflection. So our graph for this one, it should look like the last one except upside down. And it would go through the point 0, -1. Just the basic shapes, really all you need to know, though. Okay, so
I want to know, like, what would make it flip.
Flip the other way. We'll see one. We've got all 4 on this one. Yeah, yeah. So if you put a minus sign out front, that takes everything in the top and moves it to the bottom. Yeah, it's x-axis reflection. Yeah. Yeah. Yeah, we've got all the combinations on this one. So B gives us, well, time to freeze up, I guess. I don't know why it does that in here every time. Yep. Hey. I might actually not crash today. Yep. She's being really slow. Okay. This one gives us -2 to the negative x. Okay. So without the negative sign in the exponent, we saw what it would look like on step A. It goes down and to the right, down to the right, I mean. Okay. So now that we've put a negative sign in front of the x, that's going to be a y-axis reflection, right? Every time we had a positive x value, that's going to get switched over to the negative x value side. So that's going to switch left and right. So on this one, like our graph on the last one, except mirrored. Have a y-axis reflection to go through that same point. That's not my best picture. Let's see. Bad drawing, but it's going to go down from right to left. Mm-hmm. 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 It is. Mm-hmm. For A and B, it'll be, yeah, because it hasn't like shifted anywhere. It's just a reflection. So that point, since it's right on the y-axis, when we do a y-axis reflection, it stays. Yeah. Every other point we change, though. That's right. Yeah. Okay. C gives us just the basic version, and with no reflections. It just gives us 2 to the x. So that will look like number 4. That's just our basic exponential with a base bigger than 1. And then D just gives us the negative in the exponent. So D gives us 2 to the negative x. So again, when we put the negative up there in the exponent with the x, that switches the left and the right side. So if this is what we did look like, when we switch the left and the right, we're just mirrored image over across the y-axis. So it'll look like this. So if you put the negative out front of the base, it switches the top and the bottom. If you put the negative in the exponent, it switches the right and the left. So switch top and the bottom, that's an x-axis reflection. Switch left and right, that's a y-axis reflection. Questions on those? Anything in there? Okay, number 6 is really just a calculator problem. It gives us an exponential function, and then it says find some different numbers. So like find f of 1/2. Okay. On that one, that would just be 2 is what that comes out, but you can do it in the calculator. Okay. The reason why I knew that one is that would be 4 to the 1/2 power, which is the same as the square root of 4, but you can just punch it in the calculator on those. Okay. Not a whole lot to talk about on that one, I don't think. Anybody think of a question on those calculator ones? Okay. Number 7 says here's the equation in exponential form. We got 2 on this one. So A gives us log base 6 of z equals 1. And we want to put it in exponential form. So in exponential form, what's our base going to be? Yeah, so our big number is 6. And then it's going to be, what's our exponent? 1. That equals z. Yep. So just an equivalent equation there. B is this log base 10 of 3 equals 5t. We want to put that in exponential form. On this one, our base is 10. It's going to be to the 5t power. And that equals 3. And nothing to solve on these. We're just changing the form of the equation. Okay. Number 8 is going the other direction. It's going to give us some exponentials and tell us to put it in logarithm form. Okay. Again, we got 2 of these. So the first one is 3 to the x equals 50. If we want to put this in logarithm form, we're going to have log base, what? Base 3. Right? That's our big number. Is our base on the left side. So log base 3 of, what's our argument in our logarithm? It is 50, yeah. That equals x, yeah. And so if one way seems easier to you than the other, right? So like maybe it really clicks go in one direction, like maybe it's at number 7 click better, and number 8's a little trickier, then you can always think about it in reverse after you get it. Make sure you, right? So going from this side to that side, we would have 3 to the x power equals 50. And that matches. Mm-hmm. I'm sorry. Mm-hmm. Yeah. The same thing. Okay. Yep. 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 That's what we're doing. That is all we're doing. And B part is 3 to the 5th power equals W. Okay. Again, we would have log base 3. So when you have one up there already, it makes it easier. Log base 3 of W equals 5. Yeah. Okay. Mm-hmm. And I've seen people, teachers do things like you start with the base and it's to this power, it equals that, and they'd like make an L out of it. I can't do that, so make it an L because it's going to logarithm form. And then I think with the other direction, you turn it into an E where you have a limit. I can't do that, so just have to remember, I guess. Okay. Number 9 is another one of the graph matching questions. This time we're dealing with logarithms. And so it's one with the 4 graphs, and it gives us 4 different functions and tells us to match the function with the graph. So we'll just go through one by one again. Okay. The first one gives us log base 2 of x. So we don't have any negative signs in there. No transformations have been done on this one. So this is just our basic logarithm graph. So our basic logarithm graph comes in from the bottom, and then it almost goes horizontal. And then what point do our logarithms go through? Exponentials go through 0, 1, so logarithms go through 1, 0. Yeah. So our basic logarithm with a base bigger than 1, and that's what we're going to get. I may just give you like the function and then have 4 graphs and say match it. Yeah.
Okay.
Yeah. Probably be the easiest way for me to do that on the test. Okay. B part, it is nice starting off with that one though. Then we have that one to refer back to. B part, the change we're making is we're putting a negative sign with the x. We'll have negative x. If we do that, if we put the negative sign with the x, that switches the left side and the right side. That's a y-axis reflection. And so I graph this time like that. And it would be through the point -1, 0. C part gives us a negative in front of the whole log. So if we throw a minus sign out in front of the whole thing, that switches top and bottom, and it takes all of our positive y's and turn them into negative y's, and vice versa. So we're starting with A part, flipping the top and the bottom. Oh, sorry, this thing's going crazy up here. We'll have something like that. And then the last one, we're going to have both minus signs in there. These are the ones you have to think a little bit hard on sometimes. So negative log of negative x. So we take our original logarithm, like this. We switch the right and the left, and we're coming up and going to the left. And then switch the top and the bottom, we're going to be coming down and going to the left. We'll have this graph. Questions on those? Yeah. Yeah. Just the negative log on that one. 10. We're using our rules or our laws of logarithms. And is a mix of both directions, so part A tells us to expand this expression. X log of x to the fourth y over z. Okay. So you can take more than one step to do these, it's fine. So the first thing I see is we've got division in there that I want to get rid of. So we could rewrite this as log of x to the fourth y, and then log of z. Since it was division, what's our sign between our two logs? Yeah, subtraction, minus sign. Yep. And then on the first one, we've got x to the fourth times y on the inside. So that will turn into plus, yep, addition. So we'll have log of x to the fourth plus log of y minus log of z. And then we've got one more thing we can do, because we have that x to the fourth power. So if we have an exponent inside of a logarithm, what can we do with it? Remember that one? Put it in front, yeah, put it in front like coefficient, so that's right. This whole thing, when we get it fully expanded, we'll have 4 log of x plus log of y. I'm just dropping the parentheses because we don't really need them. Minus log of z. And B part, I guess it's because it's random. B part starts with this, okay? And it goes the other way, so that's not real challenging. Okay, so B part says combine. Let me switch it up a little bit because the one I have is exactly, we'll end up exactly where we started on the other one. So let's see, let's do let's just do that one. Okay. So go in this direction, we do want to be generally a little careful and do a certain thing first. So usually we want to, if we have any coefficients, we want to change those to exponents first. It can get really tricky if we don't do that first. So here we can take the 3 and move it to the exponent position on the y. Okay. And then to combine these two, it's subtraction, so it's going to be division, that's right. So we'll have log of x over y to the third.
Over log y
Yeah, it would be, because the division has to be inside the logarithm. Okay. Yeah. What I thought you were going to ask is, could we, this one, well, hang on, from here, if you want to, you could write this one as log of x plus log of y to the negative third. You could do that, and then we end up with log of xy to the negative third, which is log of x y to the third. could do it that way. Yeah, the division has to be inside the logs. Yeah, yeah. Other questions on those? $11 is just another combine that's almost exactly the same as that one. So we will do 12. Do 12. A little bit different looking. We've got log base 4 of 5 xy. It says to expand this expression. So yeah, log base 4 of 5. Yep. Yep. That's it. It works. And if you want to take, if you need to take 2 steps, that's fine. You can do it in one. That's fine too. Okay. That one we had. These are all multiplied together at 5 times x times y, so they all turn into addition. We don't have to do anything to the base. It just stays the same through the whole problem. And then one more that's just slightly different, not much. And this one says combine the expression. Gives us log base 4 of 6 plus 2 log base 4 of 7. The only real difference here is that we have all numbers. We don't have variables involved. And then again, we'll take that coefficient out front, move it to the exponent first. Nothing changes on the first one, but then that's log base 4 of 7 squared. Since that's a number, we can calculate it. So 7 squared would be 49. Okay. And then to put these two together, it's addition, so we're going to, what? Multiply, yeah. So we have 6 times 49. And then 6 times 49 is, looks like it's 294. And that's all we can do there. Questions on those? Any of it? Not as much material on this test, so maybe it'll be a little bit easier to study for at least. You're welcome. Maybe. Okay. All right. Well, that is it. I will. If you have other questions, feel free to hang around. But that's all I have. So, and I brought the wrong sign-in sheet today, so we won't worry about any of that.